this will be a short video. So I just want to do some refactoring. I have this general DAG data structure for directed acyclic graphs. And most compiler stages that kind of have this representation of the program, they use this data structure. For example, we start with the bacon and toast, which are like just the syntax tree of the program. They don't have that yet, but everything from that point on basically should use the DAG. The egg, the next compiler stage, the expression guided graph, uses the DAG. Then next stage, the yogurt, your official graph using resolved types, also uses the DAG. Next compiler stage, the pudding, also uses the DAG. Then the next compiler stage, the pesto, I think this doesn't actually use it. That's what I want to change today. And then the stage after that, the waffle, it uses the DAG. So basically I just want to make the pesto use the DAG as well, instead of having this ad hoc expression thingy in here. The way it works currently is that the function has the slice of expressions, and everywhere in the actual expressions it just uses IDs to reference other expressions, and an ID just contains an index into the slice, which is a bit confusing and not really documented from this arrangement of types. So I want to rather use the DAG directly, and maybe even document that a bit better than it currently is. So most compiler stages have represent the program as a directed acyclic graph. This file contains a common definition for that. Expressions, nodes in the DAG, expressions in plum don't refer to other expressions directly, but only their ID. Well, that doesn't really explain it. Most compiler stages represent the program as a directed acyclic graph. DAG. This file contains the data structure for that. The DAG key owns the nodes of the graph. Usually these will be expressions and so on. Yeah. The expressions themselves only contain IDs, which can be used to refer to other expressions in the DAG. I don't know. Yeah, something like that. A reference to a node in a DAG. The index is the node's index in the DAG's nodes list. Beautiful. Okay. I like that. is just a bunch of nodes. Boom. Okay. Yeah. Maybe having a uniform ID type instead of compiler stage specific IDs, such as putting ID, Pesto, ID, etc., does make the program a bit less type safe. But it simplifies IDs. We can have generic. For example, we only need one implementation for equals hash and write. Yeah, these down here. Actually, I think I might switch that. Yeah. First have the ID and then the tag. The ID and all things that only concern IDs. Yeah. Yeah, I like that. Okay, so a reference to a node in the tag. The index is the nodes. Yeah, that's fine. Yeah, I like that. Okay, yeah, nice. This is documented a bit better. Okay, so in here, this will just be the DAG. A function will have a DAG of Pesto expressions and then a Pesto body. We no longer have Pesto IDs, we just use the generic IDs for DAGs. And then in here, each Pesto expression has a type and an operation, which is defined in here. Amazing. Yeah, let's maybe aligning that as kind of, I don't know. Don't really need that, you know. Yeah. Cool. All right. So we have these. We have these. We have this. Next. Yeah, we don't need to be able to print IDs because we just use the generic ID printing for that. Indentation could just be indentation. So we have this generic, what is it, indentation type. I'm just gonna add a to-do. Yeah, because that's not what I'm focusing on today. I'm just looking at converting that to a DAG. This is fine. Yeah, this is fine. Yeah, this right here, I think I can simplify that. So this doesn't need the pesto fun, it just needs a DAG of pesto expressions. Same here. Just needs the operation and the DAG. Okay. Yep. For the body, let's see. Fun. No, this will just be DAG. Yeah. Exactly, converting pesto to waffle. Let's maybe first fix the something to pesto. Yeah, pudding to pesto. Do we have pudding ID in here? Pesto ID. Yeah, we do. Pesto. Yeah. Okay, let's turn this into just ID, I guess, and pudding to pesto also just ID. Okay, so that doesn't work. Oh, hang on. In the pesto, we do have a hash function and an equals function for IDs, which we no longer need. Yeah, we also don't need this, because that's just common stuff on the DAG. Okay, so I guess let's go through this. So constructing a pesto, we can do that. We can associate operations with types. We have a pesto nothing. We have a return type of a function. That would be getting the return thingy and then the type. Sure. Then we have this, the pesto fun builder, which we don't need. That's just the DAG. And this right here is just a DAG of pesto expressions. Pesto fun builder, nope, just create a DAG. Body builder, indeed, of a DAG. Turns a pesto body builder of the DAG. And this is DAG.put. Clean. Okay, so creating something on the pesto. Nope, that's just DAG.put. I'm pushing something to the body builder, indeed. That is builder.dag to put that expression that returns an ID that we then push to ourselves. Nice. Then getting something from pesto fun builder, not needed. Getting something from the pesto body builder, just gets it from the DAG. Finishing pesto body builder with a return ID is a pesto body with that. Okay. Finishing, nope, not needed. We'll just inline that as necessary. And I'll just follow the trail of errors and fix all of those. Yeah. So, from builder, no, that's just DAG. Yeah, the builder is a body builder of the DAG. Beautiful. I'm not sure. Let's make the DAG directly mutable in here. For every parameter, we do this. Yeah. And then we don't do build or finish. Oh, well, we do, but in here we just return pesto fun of the DAG and the builder and the body. Something like that. Let's see. DAG is already a reference, sure. Is DAG used, by the way? Fund.DAG. It's not really used anywhere else, so let's keep that like this, maybe. Okay, 408. Oh, let's see. That. Compile closure free fun. Just creates a DAG of pesto expressions. It creates a builder of that DAG and that pesto type. It says captured variables is builder push or something. With free stuff, sure. And in here we put the fun, which is a pesto fun of the DAG and the body. Okay, same for the drop fun and probably also the dupe fun, but we'll get there. So we build a DAG of pesto expressions and we create a body builder with that DAG, just so that in the end we can just say in here, yeah, here we can say the function is a pesto fun of the DAG and body. Oh yeah, here we need to do that. And the same here. Could just use DAG directly, I think, because it is available. Yeah. Oh, fun. For every switch case we do that. Ooh. Sure. Okay. Phew, that was kind of painful. Dupe fun. Same thing. And in here, yeah. Builder.finish of something. Yeah, but this is just a pesto of the DAG and body. Okay. Oh, hang on. Oh, next compiler stage. Like the one after the pesto. Fair enough. So we just get the expression from the DAG. Yeah, I guess we'll just change these. Still works. Amazing. I am wondering like in many places we do dag.get something dot type. Here's as well dag.get something dot type, dag.get something dot type, dag.get something dot type, and so on and so forth. I guess. Yeah. I'm wondering if I'll just have a general like type of thing on the DAG, which just assumes that the thing has a type. That would be pretty cool, I think. Like, it would be a cool usage of, this kind of compile time duck typing. Yeah, let's do that. So in here, let's have a type of, given a DAG and an ID, we can return something that's going to be inferred. And we just do dag.nodes.get ID. Hang on, just dag.get ID dot type. This assumes this function requires the T to have a type, a field called type. Boom. Just do T, but that doesn't exist. Indeed. Now it does. Hang on. First of all, let's push stuff, but not that. Use dag and pesto. Okay, and then I do that. And basically now I can every like these, I can replace this with type of parent. Ooh, that is clean. Let me zoom out maybe, so I can just make sure to put things on a single line when that works. Oh. Not quite. Oh, hang on, builder.get. Builder is a body builder of the DAG, which is Pesto expression, so this is a Pesto body builder. Yeah, and this does indeed have a get function. I think I'm going to remove that. But then I would need that. Oh, hang on. I can't just do that. Yeah, okay. Yeah, just do dag.type of key value. Okay, here we don't have a DAG directly. So here we do need to do builder.dag dot type of condition enum dot unwrap dot get case dot key. And body is a body builder. Body to push, push get. Yeah, let's remove the get, I believe. Egg to yogurt. How is the builder defined in here? Or in here, I think in here. Where's the yogurt builder? Yeah, yogurt body builder. Let's remove the get function here. Yeah. I don't know. Maybe that is. Maybe it's fine to kind of duplicate that on the builders. I'm kind of torn, you know. Egg bodybuilder, you can just immediately do type of. Yeah. Let's see. Ooh. Okay, on the egg we okay, I believe I'm not sure. I'm not sure how to manage that. Oh, I do this. Yeah. That's cool. yogurt bodybuilder. Yeah, I think I'll have that. Yeah, getting an ID from a bodybuilder and also getting the type of something. Yeah. Yeah, so this could just be, yeah, push param is just, oh yeah, no, that is builder internal stuff. Yeah, this is body.typeof. Yeah, and I guess same for the pesto. So something to pesto, let's see. Dang, the vast majority of code is just closure stuff. Okay, yeah. I think I'm gonna actually split it in multiple files later on, but not in this commit at least. So getting something from the pesto builder, getting the type of something. Yeah, you know what? Let's, like, I think it's a bit cursed to I think I want specialized functions. Yeah. Plus, this video right here will turn into more of a general refactoring session instead of only, you know, strictly doing the DAG stuff. Okay, yeah, that works. So let's maybe commit that first. Although I'm still, yeah, okay, that's fine. Okay, I do want to have like a general DAG dot something, like in the egg. Param types of an egg fun. Yeah, that makes sense. This is also fine. In here though, pesto to waffle. So we have a pesto fun. Oh yeah, we get stuff from the DAG. Yeah, that makes sense. Yeah, this right here, that can be simplified though. not the fun.dag, but the builder.dag things. So here we have a fun ground builder. Yeah, okay. I mean, it works, so who am I to judge that, right? Now let's just make sure this compiles and that it produces the correct result. Okay, but that already compiles, that's cool. Yeah, and running that, perfect. Yeah, kind of refactor that add take off on DAG. Cool. Okay, then yeah, some of these transformations, they're quite big, and I want to split them into multiple files. So this one right here, converting Pesto to waffle, contains memory layouting stuff, a lot of memory layouting stuff, which makes sense. But then this is like the core logic. So I think I want to split it into two files, and I'm going to do that by creating a folder pesto to waffle.mar, pesto to waffle, just that, and then moving that file in there, and renaming that to mod, and changing that up here to instead import that, and then doing a memory layouting as a separate memory layout.mar. And that will contain this. This really is a comment for memory layouting. Cool. All right, and here we import that as well. Memory layout. Sure. So in the main plum file, we'll need to import the correct file for that. All right, that works. Pretty cool. And I think most of the compilation stages should actually be a folder to make and kind of split these big files up into stuff that, for example, only contains the builder, only contains type stuff and value stuff. Being able to kind of separate those different things out into different functions makes a lot of sense. But first, yeah, split pesto to waffle. Into multiple files. Amazing. Then putting to pesto, same thing. Putting to pesto. Moving that in here. Renaming that to mod. Importing dot that. Importing the correct thing here. And yeah, this is type stuff. Just compiling types. So I think I'm gonna do that. Types. Like that. Yeah, then we have dupe and drop. The function generation for those. Dupe, drop, and closure free. Separate thing. And then this is the actual logic for compiling the body and expressions, bodies, functions, and the entire pudding. So I think I'm just gonna name this dupe drop free. Boom. Cool. Does this work? Yes, it still works. Very nice. So we have waffle to ground, which is quite big. We have a builder with several functions on that. And then there's the actual compilation. I see. Yeah, so let's split that. Waffle to ground. Bump, and this to mod, have a separate builder file for the ground builder and all the instructions on that. This is irrelevant because that's clear from the module name. Okay, this can go as a top level description here. Nice. And then what else? Oh, in the plumb file we need to adjust that. Okay, that works. Yeah, split waffle to ground into multiple files. Clean. What's still in a single file? You know, we have yogurt pudding, which, fair enough, that's not super, you know, complicated. Still might want to, just for consistency, put that into its own module. I don't know, but we don't really need to. Yeah, putting that in its own module, I don't know. Like, this is pretty simple. This one though, this is huge, almost 1,000 lines. So bacon to toast, let's create a module for that. Mm-hmm. Yeah. You know, just for consistency, I think I'm going to, yeah, I'm going to create modules for these as well. What was it? String to bacon. Nice. And then here, let's just adjust that. Well, down string to bacon into file into folder. Meh, something like that. And then same with yogurt pudding. Okay, and now we get to the big one, which is the parsing, you know, bacon to toast. Alright, I guess that do we want to split parsing based on these two granularities? Parsing blocks and parsing lines? I'm not sure. Okay, first of all, the line parser. I think that makes sense to also this, yeah, to kind of put that into its own file. Boom. Okay. Well, I'm wondering that, like, there are different dimensions basically. We can have things on a single line and in blocks, and we can have things on the type level and the value level. So there are many ways to order things. We could say we have one file of all the block parsers and one file for the line parsers. We could say we have one file for all types and one file for all values. We could say we have you know, one file for each semantic, like a structs, for example, and then having struct values, struct types, and both blocks and lines. I think I actually like that. Yeah, because yeah, when I change how structs in a single line are parsed, I probably also want to change how they are parsed on blocks, I think. Like if you change the character of something like, you know, they kind of belong together, I think. Okay, so yeah, this is like identifier parsing, I guess. And this as well. Names. We have identifier characters. And then we have names. We have these three different forms. Passes a non-uppercase identifier, also without punctuation. Maybe examples full, bar, plus, minus. Passes an uppercase identifier. Examples full, bar. Passes a lowercase identifier. Does not allow punctuation. Examples full bar t. Okay. Yeah. These are the different kinds of names that we have. Pretty cool. Then I think let's look at structs. Yeah. Struct.now. And this contains everything struct types and struct values on lines and on single and on blocks. So parse struct type on a line parser. Amazing. And parse struct type on a bacon. Yeah. Because that belongs together. The types. Nice. Then parse the values. Parse struct, we have that here on a line. And on an entire bacon. Yeah, I like that. You know, like if I add another language feature, for example, I'll add a single file in here, and it's pretty easy to, yeah, if you want to change something, you can really easily find that out with this folder structure. Yeah, and this structure scales by the amount of language features, not by the amount of types of values or like kinds of expressions, you know. All right, so next, enums, I guess. Plural. We also have names, so yeah, sure. So parse enums. Parse enum type on a single line. Amazing. Parse parse enum type on a bacon. Parse enum on a line and on a bacon. Clean. Next, lambdas. Parsing lambda types. Oh, hang on. Oh, lambda types cannot be, they're always on single line. Interesting. I mean, I guess that makes sense. Like intuitively, I don't know how to put that on multiple lines. But you see, this is something to be aware of. Yeah, parsing values. Well, parsing a lambda. And here it only works on a bacon, not on a line. So I'm going to add a to-do here, I think. Allow lambdas on a single line. For example, in our playground file, in here we can't put that lambda on the same line as the map function. That's kind of weird. All right. Yeah. Oh yeah, switch. Sure. Oops. Switches. That the plural is kind of weird. Oh no. Yeah. Cool. Okay. Oh, hang on. This is only used in params, right? Yeah. Yeah, it is. So let's move this in here. Oh, I see. It's also used for function definitions. I could turn this into fun as well. Parse fun. Lambdas and funs. Why not? Still a lot of stuff. Oh, we'll get there. Parenthesized. first I'm gonna factor these out. Like int simple self-contained yeah. Cool. Strings. Again, this can be much more complicated. Allow multi-line would make sense, I think, maybe. Yeah, so strings, our thing. And then we have, well, parsing type expressions, basically. Oh yeah, here. Parenthesized is a concept that exists on the value and type level. Let's do that, yeah. These are kind of expressions, and these are value expressions on the line and bacon. Yeah. Let's move all of this into here. Nice. Yeah. Value expressions and type expressions. I think we want to merge these. Similar to how we do that for value expressions. Allow having this, instead of having parse type atom, parse type expression, and so on, just have these allow dots, allow white space parameters. I think only allow white space, but yeah, kind of unify that. Okay. Yeah, what's left in the mod? We have declarative parts, true. Imports, exports, type definitions, function definitions. With imports, exports, I see that. Let's actually put that together somehow. parse type def, but not function definition. Parse fun def. Oh, that was in here, right? Lambdas funds. Yeah. Sure. Let's only call this lambdas, and then have defs, where we have a function definition and a type definition. Nice. Oh, that is clean. Okay, so we have the parser, we have names. Oh, let's do that alphabetically, I guess. Defs, enums, expressions, imports, exports, ints, lambdas. What is, well, ourselves. We have names, we have parentheses size ones, we have the parser, we have strings, we have structs, and we have switches, I guess. Clean. Wow, that works. I like that. Yeah. Turn bacon to toast into multiple files. That really, like, cleaned up the code, I think. Instead of 1,000 line file, we now have, it's kind of separated out, and it's a bit better to get an overview over that. Nice. Yeah, I like how this looks. Yeah, I think that's it for today. Next up, I guess, would be to implement some more language features or do some more refactorings. But this is a nice cut, I believe. So, see you next time. Bye.